I never waited for the email today. Mm, remove that. Am I live? 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 Mm, remove that. Am I live? Am I live? Am I live? Am I live? Okay, cool. It seems like I'm live. Sorry. I just had a ramble for 15 minutes by myself. So let's get this started again. Hi, everyone. Welcome. It's Monday morning. We're doing some live coding. And as with live coding, things might work, things might not work. And I think this Monday is one of those where we might have things not working. Albeit this time we know the reason they're not working as we go into them. So that's a big difference, especially on other Mondays. And that means it's getting better. Also, I'm quite sorry to have started it late. Well, I didn't start it late. I just didn't realize I was my streaming wasn't live. But I think we've sorted that out. My streaming is live now, and this is good. Okay, so what do I intend to cover today? So um, more as is usual with this Monday streams that we do. What I want to stream today is I'm looking to cover. I'm looking to show what the reality is when we are developing these applications. What does that mean? It's very easy for me to sit down for 6 hours, encounter bugs, and then arrange the views in like just show you what I did step by step and make it look like I did everything right the first time and it worked out. But that's not real. That's kind of entertainment because I'm just like showing you like like in real development things sometimes don't work, and that's why this is a live coding session. The live part is true. Things might not work. This is something that happens in real development all over the time. Okay, but hopefully, even if things do not work, what will end up happening is we will discover how to do things where we need to go in order to fix things. I think this is more important information than actually, oh, here, look, my LED is blinking and everything is working. So, what do you do when things don't work? And that is more what we hope to show in this streams. Okay, cool. So, the point of today's stream is to discuss what we need to do and, if possible, try and achieve it, although we are hitting a roadblock. What do we need to do in order to add an external sensor onto a board? Let's For this stream in particular, let's consider an existing development or evaluation board. What do we need to do to integrate an existing board with a standalone sensor by way of Zephyr? Okay, so the aim today is to add this time of flight sensor module, which is the VL53LDK, I think. VL53LDK. Yeah. But this is which is the VL53LDK sensor, time of flight sensor from ST. We want to integrate this sensor with this evaluation board, which is the NXP 1060 board. Okay, cool. So let's begin from basics. Just a recap of basics. In Zephyr, let me open a Zephyr project. Actually, let's look at the Zephyr project that's running on this right now. On Zephyr, it's quite easy to use a peripheral or a sensor, let's call it a sensor that is attached on board the device. In our case today, it's going to be the example today is going to be the blinking LED here, which is blinking at every 3 seconds. It's quite easy. And the reason it's quite easy to do this, like you can, as you can see here, all we did is we just pulled in a macro to define the LED. Then we constructed the LED or initialized the LED, and then we made sure the LED is initialized and configured correctly. And what this is the key part of the code. Once it's initialized correctly, we basically just, you know, flip the state of the LED every 3 seconds. It's quite easy to do that on Zephyr because you just pull something that is defined. However, what happens when you want to define, when you want to add a new sensor to your system that is running on a new sensor to your system that is running on Zephyr? What do you need to do? So let's explore what process you need to follow through that to get that achieved. So the reason you can just call a constructor on this LED and just get it going is because this LED is defined in the board's device tree. So let's go and look at this board's device tree. Okay. Let's go and look at this board's device tree and see how we're using it. So here's a device tree. I'll quit it. I'll quit this. Um, Shame on the internet. Shame on the internet. Shame on me for not being able to exit Vim on the internet with everyone watching. Cool. So I'll just go back to home so that we can see. So I'll go to my Zephyr project repository, and in here I can go into Zephyr itself, and in Zephyr I'll go boards, and then in boards I'll go NXP, which is my manufacturer, and then in my manufacturer I'll go MXP, MIMXRT 10 something 1060 EVK. Okay, so that's the board I have. You watch, that's the board I have. In this board, we're looking for something for we are looking for a device tree file. So let's look device tree file DTS. Cool. That's the device tree file we want. So vim mim xrt evk.dts. Okay, cool. So let's explore this file. Ha! Do you see? We have aliases green LED. So what is green LED? Let's go and find green LED. Okay. So green LED is LED 1, which is on GPIO 1, pin 9, and it's active low, and it's user LED. Okay, so that's it. That's this one. So we have a device tree file that defines all the devices that are currently on board on this evaluation board. And you can look at, let's say, I think there should be, let's see if we can we find an accelerometer? Can we find IMU? IMU? Um, let me see. Let's just scroll. How big? Oh, whoa. Okay, let's look. So what I'm looking for to show is that there's an onboard. There should be an onboard. I like that. I like that LVGL has a pointer to the screen that is defined. We'll get to that later. Let's see. I want to see. This is the LCD. Okay, but that's a parallel LCD. That's a low power I2C1. We're gonna use that LP UART, Ethernet MAC, Ethernet MDIO, ADC1, ADC Flex PWM, Flex PWM1. What I'm looking for is UCAN. Uh, I want to look for. There's going to be there's going to be I think it's this one. Um, let's look at the onboard MIMXRT1060 onboard accelerometer. Gone. SPI port. It's fine. 6-axis accelerometer. 6-axis. It's connected to I2C. Cool. So that's funny because I2C, as you can see, so here's the thing, FTT533. Where's this thing? FTT53. FTT53. Mm, mm, mm. So you can see what is the FTT5336? FTT5336. Why is it FTT? FT, FT5336. NXP MIM 1060 RT. What is it? Okay, so I2C, this driver goes to, it looks like FT5336. Regardless, what am I trying to show? Right now, what we're discovering is that is this connector, which is the LCD connector, and it's also I2C. I2C can take up to 8 devices on one port. So, what am I trying to show? In Zephyr, there is a board device tree specification inside internal to Zephyr that defines the onboard peripherals and hardware that comes with the evaluation board. Now, if you skinify this and you make your own board for your own application based on this, you probably would need to define your own device tree. That's fine. We will cover that later. At the moment, we're just using what exists. So, how do you extend this? How do we add a non-existent sensor, the time of flight sensor we have here, to this? The first thing we need to do is we need to add a board overlay or a board override. So that looks like this in our Zephyr. In our Zephyr, we have a board, okay, and then in here I've added a board overlay for the LPC I2C, okay. And what you can see here is there's a status, okay, there's what pins I'm using, and then I've defined an address to this um, sensor itself. So you're going to need to do this for each. So let's say we needed to add on I2C, we added this sensor and we added another sensor, and whenever we get to this, which runs on an SPI, we'll probably add it on an SPI like LPSPI something, one or two or something or whatever. And this won't have an address, of course, but this will have all the other functions. So we'll add another and something like LP SPI or something, LP SPI one or something. here. Okay, so what's that? It's called adding a board overlay, adding an overlay, adding a device tree overlay to your project, and this enables you to connect an external sensor to your existing board. Okay, this is if your board doesn't come with that sensor, which has already been kind of sorted out by the Zephyr team, where they've developed the device tree specification already in Zephyr. So this is you adding stuff. So that's going to be the first step that you need to do in order to get things going. Now, unfortunately, the next steps involve us actually interfacing with this. Let's look at the I2C documentation. The next steps. So first of all, the reason I've taken you to the board's device tree and come back to the documentation is because if you use the documentation from beginning, you're going to end up doing something like I squared C1. Um, let's find a Zephyr I squared C example. So let's look at this one here. So it's fine. So this is, let's look at the Nordic information. So you're going to enable I squared C, you're going to include I squared C like that. But this one seems to me like, cool. You see, we're adding I squared C. This is akin to what we're doing here. So we added, on I squared C1, we added VL53LDK. Remember, I squared C on one port can handle up to, I think, 8 devices. So we can add as many as we need, okay, to this I squared C, LP I squared C1, okay, port. Now we've created the overlay file. And then what we want to do, so the reason I'm bringing you here is you might end up using an example that asks you to do this, So most examples will lead you to this. Let's go back here. Most examples will lead you to this. And this is perfectly valid. But let's do this here, I squared C1. So if we remove LP I squared C1, and we just do that, and we move here, and then we move, actually I can just do it here, source, so that we have all the things in one place, okay? And then I do west build for this board. What you'll see is our build will fail. It won't fail right now because I haven't saved that. Our build should fail. And why should it fail? Because our board does not have I squared C1 port. This is the reason I started by going all the way to the um, board device tree. So when I'm in the board device tree, I can either use Arduino I squared C. The reason it's called Arduino I squared C is because it's I squared C exposed on the Arduino headers. Okay. Or alternatively, if I'm not going to be using the Arduino headers and I don't want to use the Arduino namespace, I could just use LP I squared C1. I'm showing this part of the process because this is the part of the process that's probably going to hold up a lot of people. You're going to read some documentation, say the Nordic documentation, that's very good, by the way. Yeah. And you're going to read this and you're going to come and say, okay, so my reference manual, which is this, my reference manual, which I'll open just now, my reference manual here says if I want I squared C, where is I squared C? I2C. I2C. Pardon me. Pardon me. My computer is actually getting slow, but we'll find it. So yeah. So this is low power I squared C. when you come to this place, you look at your board, your documentation is likely to call this I squared C1, I squared C2, I squared C3, and you might not know whether in the documentation say it's called LPI squared C or I squared C1. Okay, so let's say you're used to ST like me. I'm very used to ST, and I'm going to show an ST example so that we see the relevance of me actually showing this documentation. So if I look at the reference manual for the ST here, and I look at the I squared C interface and the way they're labeled here, I squared C introduction, uh, maybe here I squared C registers. Yeah, I squared C registers, and let's say R squared C RC1. So what I want to memory map, memory and bus architecture. Sorry, I'll show you. I'll show you. So here's the thing. Here's what I want to show. Here's what I want to show. So your documentation may label things like I squared C1, I squared C2, I squared C3. And this might not be the, so in our case right now, our documentation labels it at LPI C1, LPI squared C1, LPI squared C2, and that's what is in the device tree definition. But you might have a board where this and the device tree does not match. Now, if this and the device tree does not match, and you come to your Zephyr project and you try do this, just I squared C1 because it's a fast port, you'll end up getting an error like this. Once you have an error like this, it's very hard. You don't know you don't know where to go and find out. So the way you fix this error is by looking at, if you look at your own board's device tree, in the Zephyr repository, you'll find out the name of the port that you want to look for. And once you have the name of the port or the convention that is used, it's quite easy to fix now this fail. Okay, LPI squared C1. Okay, cool. Low powered I squared C1. Okay, cool. Let's build. And this should generally build our project, and this should work. Cool. Okay, so our project's building, it means code compiles for this. And if we do flash this code right now, we can change this code. Let's change this code and make it blink at 1000. Just so we make sure West flash, it should do a rebuild. Just so you can see right now it's going at 3 seconds. And then now we are flashing, and then let's look at it's coming, it's coming, it's coming. So now we should have a blink at 1 second, which is boom, 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 boom. You see, basically the code works. It compiles and it works. Okay, now we come to the next problem that is blocking me today from successfully demonstrating this I squared C driver for you. By the way, if we were to go on and do this driver, it's quite simple. So we would just it's basically as simple as the it's all here. You'll have to define a node for the device, and then you'll have to do a constructor for the device and initialize it. Then you'll have to check the configuration if you want. This is all. You don't have to do this. You don't have to do this. I'll show you. Uh, Control Z, Control Z, Shift space, Control Z, Control Z, Control. Command that. Okay, cool. So even with this commented out, and I'll explain why. I'll explain why just now. Even with this commented out, our 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 board should still Flash should still build. Okay, it should. I'm getting links. This is just error handling. This is making your code production ready. If you're prototyping, you don't exactly need error handling, but error handling is so there's a concept where like 20 80% 80% of the work takes 20% of the time, and then 20% of the work takes 80% of the time. Once you build your application, ideally, as you build more applications and as you get more experience, you kind of build in error handling as you go. But in your beginning projects, you're going to build an application and then retroactively add error handling because you'll start encountering errors, timeouts in the field, and you need to add handlers for those errors. Okay, so it's basically the same as we did. We're going to construct the I2C device. Once we construct the I2C device, then we will be able to start sending and receiving messages from it. And let's look at the Nordic documentation. See, we're going to define a node. This node will be our sensor. In our case, it will be the time of flight sensor VL53LDK. And then we're going to construct our node, and then we're going to check if our device is ready. Then from there on, we can write or read from the device. This is the advantage of Zephyr. It comes with HALs for devices that are open source and that are not. From what I've from what I've from what I've experienced, this HALs are specific to each device. So they're not almost like cross-platform developed, like say the some other vendor HALs, which means they act specifically on the device that you. And there's a lot of work here. Another thing. So if you're looking for work, if you want to prove that you can do embedded development work, it's a good season right now to go and do contributions into the Zephyr project because they need a lot of HALs developed and they need a lot of sensors integrated. And basically, you can add code into the Zephyr project as a career advancing move at the moment. So this has gone into so many segues. But what is stopping us today? So the reason I'm not going with my I2C demonstration today is because as I was testing this out today, I could not get the power signal out of the J24, J25 headers. So if we look at the hardware guide, there is a hardware guide. There is a hardware guide. I have. This is the documentation. This is the user guide. This is the hardware users guide. So this is the MIMXRT1060 hardware users guide. In this hardware users guide, we have a list of Arduino headers. Yeah, yeah. These are these Arduino headers. So that's J22, and that's J24. This is J23, and this is J25. So J22, J23, J24, J25. I touched them correctly. Cool. So J25, this guy over here, has 3-volt and ground pins for my board. My difficulty at the moment is that I'm not able to, of course, I did something and now my board is not blinking. My difficulty at the moment is that I'm not able to get power signals out of this 3.3-volt line and the ground and the 5-volt line. And that's difficult because I need to use those 3-volt lines with this I2C SDA SCL lines here to communicate to the sensor that I have. So what I now need to do is I need to go and sit in a couple of NXP forums and because this board is quite huge and it has a lot of switches and sensors and it has a lot of switches and jumpers. And I need to manipulate these switches and jumpers so that we can get power to those to these headers. Okay, so at the moment that's the difficulty. There is no. Why isn't that plugging in fully? Why is that going further? Ground, ground. So I'll look it. I'll check again now. Just gonna flash to make sure my thing works. My blinky blinks. No, of course it doesn't. Of course it doesn't. I know this problem. Okay, let's see. Yeah, now it's working. Okay, so now it's back to blinking. I don't know what I touched, and then it didn't blink. But my power, and just as you're here, because I did all of those changes. Let me quickly check that that is still the issue. So I'm trying to get 3 volts out of these lines, and if I can't, I can. No, no, no. So I'm not getting 3 volts, but out of the LED. I see. So is it possible? Is it possible that they're labeled in the wrong way? And this is ground, 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 3.4. Wait, 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 wait. Ground, 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 ground. So ground, ground. 5V. Let's try this one and see. So ground, ground, 5V. So that's a ground. That's 5V. No, no. So it's still not working. My issue at the moment is I need to dig a bit more into these headers to find out which header will give me what power. And then once I found out which header is giving me which power, then it's quite simple then for me to hook up the sensor and demonstrate the code that I've shown you. But the code demonstration would still, if I just booted up my stream today and I just demonstrated the code, this is what you do, this is what you do, this is what you do, you would still run into this issue. So what if your board doesn't power up properly? What do you need to do? So like right now, I'm going on the NXP forum, and I'm going to ask this question for a couple of hours, and I'll see what I can get. Number two, what if you need to do an overlay and you're defining the overlay and you're getting overlay errors after you're adding something you think exists? Where do you go looking? So you need to go looking into the board's device tree definition already. Okay. Um, how do you use Zephyr to advance in your career? So you could, like I said, the Zephyr project at the moment. Uh, so let's go to the GitHub. So the Zephyr project, Zephyr GitHub. Now I come in here, and then I know I go to open on GitHub, and then basically the Zephyr RTOS project here You can, there's quite a bit of work in the Zephyr project on boards. Well, mm, yeah, there was boards. So here in boards, there's quite a few of these boards that don't have a lot of things developed. So if you have a board that is on here that isn't covered by Zephyr, which there's a few, or has a driver that isn't covered by Zephyr. Let's actually just go into my LP. So let's see, can is defined. Okay, what about inet? So let's say you want to use BLE. Okay, you have a board that has something like BLE and it's not covered in Zephyr. As someone who's looking for work, contributions to Zephyr is going to help your CV. You know, if you're looking to add more production experience of code into your work, you can easily use Zephyr for this because you can contribute to Zephyr. You will learn how to develop embedded products. And additionally, after learning how to develop embedded products, you will also have the opportunity to have publicly attributable work to your name. Okay. What else? Okay. I don't know. So let's recap what we've done today. We've explored what we need to do for for us to add an external piece of hardware onto a board. And we've explored what we need to do with Zephyr in order to integrate an external piece of hardware with an existing board. And we've explored this using the I2C peripheral as an example. So as a recap, look at your board's device tree specification to understand how existing devices are defined so that you can add your own in a way that works. Look at the Zephyr documentation on how to use the protocol you want. The Nordic documentation come in handy because there's quite step by step, and then you can modify by yourself after. And then you need your of course, you need your device's user guide and your reference manual to find out which peripherals you have, what addresses they are, because later, when you actually go to define different peripherals that don't exist, what you'll discover is that you'll need to know their memory locations. And this you can find out from the how do I say it? You can find this out from your reference manual. You can find this out from your data sheets, yeah, and your technical programming manual. So, what's today's problem? Today's problem is that I cannot get the power signal out of this board so that I can actually put on my time of flight sensor module, which is something I'm probably going to figure out within the day and I'll post. And as usual, by the next time I stream this again, I've gone past this problem and we'll be encountering a different problem. I hope Mondays, I want to, let me see, any questions? Marvin, you're the one who's here. You're the one who's likely here. Do you have any questions? Can I explain something better? Waiting for questions on live chat. And if you have any questions, there's always a Discord link down below. There's a project link down below that you can comment on and you can jump on and you can see. And I think for today, we covered how to add new hardware to an existing board using Zephyr with some protocol. And in our example today, it was I2C. I didn't manage to do it because I'm debugging power modes on this board. Of course, a shorter video will come later down the line that just shows all the successful steps. But I have a feeling those kinds of videos are not what people want. Or those kind of videos are not the videos I want. So thank you, sir. So yeah, um, we'll leave it at that today. We'll come back to another stream later this week. Let me go find out how to fix the power issues on this board. Um, thank you all so much for coming. Thank you all for watching this, and let me know if I can do. Let me know if you want me to do some specific explanation of another board or thing. Yeah, yeah. The solution is probably. So Marvin says he's pretty excited to see what the solution will be. Just like the last. So in the last stream, this switch was the problem. So it turns out for this switch, where's the switch? This part, this bootloader switch. It turns out for this, for this board, for you to flash into it, you need that switch set at 1100. And then for this board to boot up into the firmware that you flashed on it, you need it to be 0010. And it's going, I can guarantee you that my solution to this problem is going to be some sort of switching or um, or jumper that I need to change, and I will suddenly have power on this board. In the meanwhile, thank you so much for attending. This has been awesome, and look forward to seeing you. Let me know which topics you want me to cover. Cheers.